In a previous video, I showed how I built this server rack for my Raspberry Pis and my 3D printer. Since that video, I've opted to move my 3D printer to its own enclosure, but that's left the server feeling a bit empty. Well, today I've started to fill it in and I've built my own home server and NAS solution. Now the server I built is a bit overkill for a NAS implementation, but I'll get to that later. Building a NAS was a big thing I've been pushing myself to work towards because before building this, I didn't really have a solid backup system. For most of my life, my backup strategy was one copy of my local machine, and then a copy in a third-party cloud like GitHub, Apple Music, or Google Photos. Then in college, I bought a 1 terabyte external hard drive that I backed up all my important schoolwork and other files to, and carried it around with me in my backpack. I even wrote a few basic shell scripts to automatically copy files from my desktop and laptop, and only overwrite or replace the files that had been edited more recently. It was more or less a glorified giant flash drive, and it really did not like my Android project workspaces and their hundreds and thousands of small files, but it got the job done. At any rate, this hard drive went basically wherever I did since it was my backpack, and this essentially acted also as my off-site backup. Fortunately though, 2020 came along, and for obvious reasons, I no longer had in-person classes. I also soon graduated and took a full-time position that's more or less fully remote. Needless to say, I no longer use my laptop, and I also don't go many places with my backpack anymore, so this external hard drive really isn't off-site. And lastly, it's only 1 terabyte, and my video files alone have now eclipsed that mark. I really need a backup solution. So a NAS it is, but you have two choices when it comes to a NAS. One, go to a computer store and buy a commercial NAS product and use that. For most everyone, that's the easiest and likely best solution for you, but if you are a more tech savvy and want more control or a more custom solution, there is the other option of building your own NAS. Obviously this comes with a lot of drawbacks, the biggest being the higher setup and maintenance costs of your time, but you also have much greater choice in how it all works. Now I could go on and on about the pros and cons for this, but the bottom line is, do you want to be responsible for setting everything up and making sure everything works together, or do you want to offload most of that work to a company to do it for you? All I'll say is you want to make sure you work towards a 3-2-1 backup rule. You have 3 copies of your data on 2 different types of media, with one of those being off-site. Now, I'm not perfectly at this 3-2-1 rule yet, but with a NAS, I will have 2 copies of my data, one on my PC and one on my NAS, and then a good chunk of my data will also be in the cloud on the aforementioned platforms like GitHub, YouTube, Google Photos, etc. In the future, I plan to look into using Amazon Glacier storage to fill the gaps and act as a last resort recovery as well. This is great and all, but why did I pick an overkill NAS solution instead of buying an ASUS store per se? Well, for me, it was the benefit of having a more open and moldable system to do more than be a NAS. I don't know what things I may need in the future, and Raspberry Pis can only do so much. So to have a more powerful server that I can throw more intensive workloads on, like running a game server, is a huge plus. Additionally, I also want to be able to remove the SD cards from the Raspberry Pis and have them boot off the network, which, while I'm sure you can do on something like an ASUS store, I feel more comfortable in getting this all working on a non-proprietary system. Also, be sure you're subscribed so you don't miss my video where I do go about the network booting my Raspberry Pis. But at the end of the day, building my own multi-purpose server just seemed much more enjoyable to me. Okay, enough with all the talk, let's get to actually building the server. I'll have a full parts list in the description below for those who want to see it. But to start, I picked out a relatively cheap but highly rated server case from Waswell. I really didn't need anything special, and I opted for a 4U size case for 2 major reasons. Firstly, it's easier to build in and work with its much larger internal space, and secondly, because it allows the whole system to run much quieter. Server-grade components are known to occasionally sound like jet engines when their fans spin up due to their small size requirements, but still needing to move a lot of air. By opting for a 4U server chassis, I can install normal 120mm fans that will stay much more quiet relative to their 1 or 2U counterparts, and when the server is located a few feet behind me, keeping it quiet is a must. Plus, I'm not really lacking the server space. I first replaced both the rear 80mm and front 120mm fans with ones that supported regular motherboard fan headers, instead of the Molex connectors the fans that came with the case used. The front 120mm fans I used were some generic Antec fans I had laying around and are decently quiet in my existing computer. For the rear 80mm, I bought 2 Noctua NF-A8s because Noctua is a reputable brand that makes solid quiet fans, especially at the 80mm size. While on the topic of the chassis, I might not be a tech reviewer, but I want to share my thoughts on this case. Overall, it's a great first case at a good price, but far from amazing. Beyond the fan quality, the front ones were installed in a rough place, and replacing them was a bit of a hassle. One of my 3.5-inch drive bays was slightly bent and thus hard to remove from the case. The drive sleds are plastic and don't seem to actually fit the drives either. I ended up ditching these so-called easy mounts they came with and were instructed to use, and just hard mounted them into the sleds. Again, these are just my thoughts on it. Anyways, I progressed on with installing the rest of the components. For the CPU, I went with an AMD Ryzen 5 5600G. Again, a Ryzen 5 being overkill for a NAS, but on a general purpose server, it's a good middle of the line performance CPU that'll be plenty powerful for the workloads it'll need to handle. The key part of the CPU though is the G bit, as these CPUs have built-in graphics, which allow me to go without a graphics card for this build. There is zero need for one in the first place on this type of server, and given the graphics card's market when I built this, it saved me a nice arm and a leg. Also, the CPU has a mere 65 watt TDP, and in case you haven't gathered from my love of Raspberry Pis and other low power devices, I love the more energy efficient options and working towards being more sustainable and eco-friendly. I would have actually loved to use a Ryzen 5 5600GE, as those has an even lower TDP at just 45 watts, but unfortunately those CPUs aren't available for the retail. Oh well. So the CPU is installed into an ASRock motherboard with a CPU fan right behind it. Originally, I was going to use this Noctua low-profile fan because when I originally chose all my parts, I wasn't 100% set on a 4U chassis. Unfortunately, the CPU needed a conversion kit to mount this cooler, so I applied for a free conversion kit from Noctua and then used the default one in the meantime. Either way, both these coolers are plenty good for the CPU, and since building a server and making this video, I have received the conversion kits, but I've opted not to switch coolers yet. Also, ignore the badly rounded CPU fan cable. I went with this 32GB of DDR4 3600 Crucial Ballistic RAM as a good starter kit, with the option to double this in the future if I need. Lastly, I added a 512GB NVMe drive to act as a boot drive for the OS. After testing that it all boots up and gets to the BIOS screen, I installed it all into the server chassis. For whatever reason, I had to fight with the IO shield to get the motherboard in, as it was just not popping into place on the chassis correctly, but I eventually got it. I will note that I still messed it up though, and got the tabs from the IO shield above the HDMI Ethernet stuck in the ports. I didn't notice until later when I went to plug it in an HDMI cable, but I was too lazy to take it all apart to fix it, so I just bent the tabs up and out of the ports to avoid issues. It was at this time I also went ahead and prepped to install the OS. I went back and forth between TrueNAS and Unraid, with both being fairly well recommended. Unraid does have a license cost, but allows me the best scalability over time, as you can easily add new drives when needed, which for someone like me is nice because that means I don't need to buy all of my drives at once. That being said, I ended up choosing TrueNAS for the community supports, but also because I think it'll be a better learning experience for me. Now with the OS chosen, I can talk about the sort of heart of this project in the actual storage drives I'll be using. Obviously it's not this drive specifically, but because I'm going with TrueNAS instead of Unraid, it's best that I get as much of my storage right now that I want, because there isn't really a way to add drives to an existing block. You generally create new blocks with new drives. So over the holiday season, using various deals and sales, I got 4 4TB Seagate iROF Pros. My plan is to put these into a RAID Z1 pool, so that way one drive can fail and I will lose no data. I would have preferred to use RAID Z2, which would mean 2 drives could fail, but when you only have 4 drives, I lose just too much space. All said and done, I'm looking at just over 10 terabytes of usable storage data, which for me should last a good few years. So with everything assembled and ready to go, I downloaded TrueNAS Core and used Balena Etcher to write the OS image to a USB stick. Next, I simply plugged in the USB stick into the motherboard, and while I was able to get to the BIOS just fine, TrueNAS itself failed to boot. After some quick debugging and multiple boot attempts, simply moving the USB stick to one of the rear I/O slots fixed my problem, and allowed TrueNAS to boot up and completely install itself onto the NVMe drive. And there we go, the server is online and TrueNAS is ready to back up all my data. The only thing that was left was to install the rack mount rails and put this beast of a server into my rack. I'm not going to go into any more details on my usage of TrueNAS because honestly I'm still learning that part, but I've slowly manually backed up my data, just now working on the automatic solution for it. Anyways, that'll about do it for this video. Again, stay tuned for my future video where I talk about how I network booted these Raspberry Pis so they run off the TrueNAS server and don't use any onboard micro SD card. But at any rate, hope you guys enjoyed this video and my journey into getting the server set up and online. Don't forget to subscribe if you're enjoying this content. That is it for me. I'll see you guys next time. Peace out.